In this lesson, you'll learn to write equations of conic sections in standard form and identify conic sections from their equations. How can you use a flashlight to make conic sections? Recall that parabolas, circles, ellipses, and hyperbolas are called conic sections because they are the cross sections formed when a double cone is sliced by a plane. You can use a flashlight and a flat surface to make patterns in the shape of conic sections. A slice at an angle produces a parabola. A slice that is parallel to the bases produces a circle. A slice that is slant produces an ellipse, so an ellipse that is not a circle. And if we cut a slice that is perpendicular to the bases, it will produce a hyperbola. The equation of any conic section can be written in the form of the general quadratic equation ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where a, b, and c are not all 0. If you are given an equation in this general form, you can complete the square to write the equation in one of the standard forms you've learned. And there they all are again in the chart. Write the equation y squared equals 18 minus 2x squared in standard form. State whether the graph of the equation is a parabola, circle, ellipse, or hyperbola, then graph the equation. Both x and y are squared, so I know it's not a parabola, so I want to put both things on the same side of the equation. And I don't have any just plain x or y terms, so I don't need to worry about completing the square this time. I can just divide both sides by 18. And I've got y squared over 18 plus x squared over 9 equals 1. So looking at the chart, that's going to be an ellipse centered at the origin. And my semi-major axis is under the y, so I'm going to be longer up and down. I'm going to go square root of 18 up, square root of 18 down, and 3 to the right and 3 to the left. So again, I know that when we draw our ellipses on graph paper with freehand, they don't come out as pretty as their computer-generated ones, but using a calculator, I can go 4.24 up, 4.24 down from the origin, and 3 to the right, 3 to the left, and we'll try to hit those points when we draw it. Instead of writing the equation in standard form, you can determine what type of conic section an equation of the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where b equals 0 represents by looking at a and c. So we know it's a parabola if either a or c is 0, but not both, because if both are 0, it'd be a linear equation. A circle if a and c are equal, an ellipse if a and c have the same sign but aren't equal, and a hyperbola if a and c have opposite signs. So for 2a, we have a and c have opposite signs, so that is going to be a hyperbola. On this one, a and b are equal, so we know our graph will be a circle. Oh, only y is squared, so this is going to be a parabola. Conic sections can be identified directly from their equations in that standard form, assuming b equals 0. If we have a parabola, if either a or c equals 0 but not both, a circle if a equals c, an ellipse if a and c have the same sign and aren't equal, or a hyperbola if a and c have opposite signs.